Okay, we're going to dive right into graphing the tangent function. So we'll go ahead in the first column and fill in the values that we have memorized, and then we will write those as a decimal so we can plot them on our graph pretty easily. So we know that tangent of negative pi over 2 or pi over 2 is undefined because that is 1 or negative 1 over 0. So we'll go straight to negative pi over 3. So in your head or graphing, you're thinking negative pi over 3 is down here. That's in the fourth quadrant, which makes the tangent negative. And hopefully you have that memorized as root 3. Now, the reason why I said that is because down here, I think it's really important for the tangent that you have the tangent of pi over 6 or 30 degrees is root 3 over 3 memorized. And also the tangent of pi over 3 or 60 degrees is root 3. If you can have those memorized, the other ones are pretty simple because you know root 2 over root 2 over root 2 over root 2 is equal to 1. So that's just going to be 1 or negative 1 depending on what quadrant you're in. 0 and undefined are pretty basic too, but it's very easy to get those confused. Now I showed you how to find root 3 over 3 in the last video. I'm going to show you what happens when you divide the other way. So if you do, whoops. Okay. So we've got the tangent, which is sine over cosine. So that's for pi over 3 is root 3 over 2 divided by 1/2. And that's going to be root 3 over 2 times 2 over 1. So you can see where you get the root 3 from. So going back to filling in the chart, I don't like doing that every time. If you want to, go ahead. It's just much easier to have them memorized. So we're in quadrant 4. So this is negative root 3. Negative pi over 4, which is also in the fourth quadrant, so that will be negative 1. This is negative root 3 over 3 because we have it memorized. 0 is 0. Now we're moving into positive values. We are in the first quadrant now. So that's root 3 over 3, positive, positive, positive. All right, so let's fill these in. If you were to throw these into your calculator, you would get negative 1.7, negative 1, negative 0.6, 0, 0.61, and 1.7. So let's go ahead and graph those. All right, so if we come over to our graph over here, and for tangent, this is one full period, okay? From the left asymptote here, it's a vertical asymptote. We also have a second vertical asymptote over here. We have an infinite number. They just keep on going forever. You'll see that in just a second. But the vertical asymptotes are negative pi over 2 and positive pi over 2. Why? Because we don't have a function there. Take a look. The graph is not defined at negative pi over 2. So there is a vertical asymptote. There should be no graph there. So if I go ahead and start filling in, negative pi over 3 is, that's negative 1.7. So that's down here. Negative 1.7 is, right there. Negative pi over 4 is negative 1. Negative pi over 6 is negative root 3 over 3, which is negative 0.6. 0, 0. And then the other way we should have the similar values, but now they're positive. So 0.6, 1, and then 1.7. Okay. And what's happening is this graph is approaching the asymptotes from both directions here. So the domain of this graph, and it actually continues. We've got another one here that's similar, and we've got another one here. Well, that's a poor example, but okay, and they go on forever. And we have another asymptote, and then we have part of the graph, and then another asymptote. So the domain is x just can't equal those asymptotes, okay? And we have an asymptote at the end of every period, and our period is pi. Our period is different. For sine and cosine, it is 2 pi. For tangent, it is pi, okay? And the range is, now is negative infinity to positive infinity. So we are going to have some values that we can't use in the domain. So you might want to write this down. This is, why is my not working? This graph here, this chart, was written by another teacher, and I liked it, and I thought, some people don't use the unit circle. Some people just do the chart. I know another teacher that did that. If you want to just memorize that, I would just go ahead and do that at least for tangent. So now here's the information that we need to know for tangent, okay? So the amplitude is still the same, the absolute value of A is in the same place, B is in the same place, except for now the period is pi. So the period will be pi divided by B. And the unit will be the same, the period, and then you divide it by 4 into nice even pieces. The phase shift is the value of x. Same thing, you take the parentheses and you set it equal to 0. Vertical shift is the same. Reflection is the same. Okay, so we have a couple differences, but not much. But the domain is important. So if you don't have this written on your notes, and I don't think you do, go ahead and write this down. The domain is x can't be pi over 2 plus pi k, and I'll explain that for all integers k. So all the real numbers except for the values where the cosine of x is in the denominator, the cosine of x can't be 0 because the tangent is the sine over the cosine. And when you have the cosine equal to 0 in the denominator, you're going to have an undefined tangent, and that's where you're going to have an asymptote. Okay, so let's go ahead and practice. All right, the amplitude is going to be 3, the absolute value of 3, which is just 3. The period is pi divided by b. In this case, b is pi. So when I take pi and I divide by pi, I actually get 1. So the unit is 1/4. So I'm going to be counting by 1/4. So now, to find the asymptotes, what we're going to do is we know that the function is not defined at pi over 2. So we are going to set this inside part of our function equal to pi over 2 and say, okay, we know that that has to be an asymptote. So if I set pi over 2 equal to pi x, which is the inside of our parentheses here, I get x is 1/2. Okay, that is one example of a tangent asymptote. So I'm going to go ahead and draw that in a different color. So I'm counting by 1/4. So here's 1/2, right? And now every 4 blocks, because we have planned it that way, is our period is over. So our period is 4 blocks. So I'm going to go ahead and count 1, 2, see, 1, 2, 3, 4. There's going to be my next asymptote. Okay, 1, 2, 3, 4. There's my next asymptote, and so on. You don't have to do that. I just kind of like to get a couple in there ahead of time. All right, so now we are going to find, for the first couple examples, we don't have a phase shift or a vertical shift. So our 0, 0 is just going to start in the exact same place. So let's go ahead and start. I'll put a little circle around it so we know that's our starting point. So now we can graph the high and the low functions or the values. So from here, from 0, if you look back in the notes right here, way down here. Oh shoot, I didn't put it in my notes here. That's okay. I think it's in your notes here. The tangent starts at 0 and it goes high, and then it's undefined, and then it's low, and then it's 0. So some people like to memorize that. I usually don't think about that when I'm graphing. I usually just graph my 0. This is the tangent, so I know it's going to approach in either direction. Instead of going up 1, I am actually going to go up 3 because my amplitude is 3. So on either side of my 0, I'm going to have a 3, and then I'm going to have a -3. And then I'm going to draw a nice, oh geez, let me try that again. Let's go straight line. Nice curve here that is approaching the asymptotes. Okay, and so then the next, they're all going to be the same. So, and you want to draw more than one. So you don't just draw one. You need to show that you know that it continues on forever. Okay, now the domain. Okay, here's this is what's tricky for a lot of people. So x can't be, and you can pick whatever asymptote you want to name. I drew the 1/2 asymptote first, so I'm going to start with that. X can't be 1/2. Okay, but then after every period, here's my 1/2. There's another asymptote. So when I add my period, which in this case is 1, I have another asymptote. So that is why, what? Something's going on with my board here. Oh my gosh. All right. So the next asymptote will be the next period. And we have an infinite number of them. So we say plus the period times k. We just call k is our natural progression of integers. So the period in this problem is 1. So we pick an asymptote plus the period times k. In this case, the period is 1 times k. So you can just write k. And then the range is negative infinity to positive infinity. All right, let's go to the next example. All right, so let's go ahead and see that we've got an amplitude of absolute value of 2. So that is going to be 2. Oh my gosh, I'm having issues with my board. Okay, 2. All right, period is going to be pi divided by b. B is what? B is the number in front of our variable here is t. Most of the time we use f of x, but here we've got v of t. So if I do pi divided by 1/3, never dividing by a fraction, I'm always multiplying by the reciprocal. Pi divided by 1/3 is the same as pi times 3. So that's 3 pi, which makes my unit, I take that and divide by 4, 3 pi over 4, that's the number I'm writing or counting by. So 3 pi over 4 is the number I'm going to be counting by. We still don't have a vertical or a phase shift, which is nice for the first couple examples. So let's go ahead and solve for the asymptotes. Okay, they got to be somewhere. This is a graph of a tangent function. So we set what's inside the parentheses equal to pi over 2, because that's where the asymptotes are. Okay, so here's my equation. Write that down. Now you got to multiply both sides by 3 to get the t by itself. So in this case, the asymptotes are at 3 pi over 2. Now we're counting by 3 pi over 4. So my first line is 3 pi over 4. And the next one, if I add another 3 pi over 4, so 3 pi over 4 plus 3 pi over 4, I get 6 pi over 4, which is 3 pi over 2. So here are my asymptotes. And I'm going to have one after every period. And I have fixed my board so that after every 4 units, 1, 2, 3, 4, I'm going to have a full period because we're counting by 3 pi over 4. So my next asymptote will be here. So basically we're setting this graph up so we can easily graph it, okay? So all our graphs are going to look similar, but if we were to graph them on our graphing calculator, you would see they look completely different. So where are we at? All right, 0, 0. I should use a different color because that's my starting point. I'll put a circle around it. And now our amplitude is 2, so my high point will be up 2, my low point will be down 2. And that is really it for your graph, but make sure you do a couple of them. Okay, the domain is x can't be, or sorry, t, right? T, oh my gosh, every time I erase, I have this problem. Okay, it's fine. T can't be 3 pi over 2. And again, you can pick whichever asymptote you want, okay? Plus the period times k, 3 pi k. Range, negative infinity. Oh gosh, yeah. We'll just pretend like that's infinity to infinity. All right. Try the U-try. Let me show you the answer. Here it is. Again, no phase shift, no vertical shift. The domain, I just picked my first asymptote. Okay, I said, all right, here we go. There it is. So theta can't be 1/2 plus the period, which is 1 times k. So it's plus k. All right, we're moving on to example 2. So we're going to have a reflection. So the amplitude is the absolute value of -2, so it's 2. The period is just pi. That makes the unit pi over 4. So I'm counting by pi over 4. No phase shift, no vertical shift. So let's go ahead and put in my asymptotes. I already know my asymptote because the inside of that function is just x. That's going to be I can throw in a